All right, let's jump right in. We're going to talk about a really fascinating, kind of counterintuitive idea today. What if, for an AI to actually remember more, it needed to read less and see more? You know that feeling, right? You're deep into a long chat with an AI, and then, poof, it completely forgets what you were talking about just a few minutes ago. It's super common, and it's not really the AI being dumb. It's actually a massive challenge with how they handle memory and computation. Okay, so here's the deal. For today's big language models, a long conversation is like a book that gets exponentially heavier with every single page you add. The longer the chat, the more of these little digital words or tokens it has to juggle. And the cost of juggling all that, it doesn't just add up, it blows up quadratically. So every new piece of information makes the whole thing way, way harder. That's why long-term memory for AI is just so slow and expensive. But what if there's a workaround? What if the AI didn't have to read the book page by page? What if it could just take a picture of the whole thing instead? Just glance at it and get the gist of everything all at once. That's the wild idea we're digging into. And that right there, that's the heart of the matter. We're calling it the AI memory problem. It's this huge bottleneck that's really stopping these incredibly powerful systems from reaching their full potential. So let's really break this down. On the one hand, you've got the old way. You're feeding the AI thousands and thousands of text tokens, one by one by one. It gets bogged down so fast. But this new idea, it's about using vision tokens. You can take that entire block of text, turn it into a single picture, and the AI can process that using way, way fewer tokens. It's a total game changer. And this cool trick has a name. It's called optical compression. This is the key concept for everything we're talking about. You take a giant wall of text, turn it into a 2D image, and then let an AI that understands pictures read it. You're basically swapping a language problem for a vision problem. And in the process, you get this massive boost in efficiency.
Okay, that sounds great in theory, but how do you actually pull it off? Well, a team over at DeepSeek AI built a special model just to see if this idea could work. So let's take a look at how they managed to squeeze all that text into a picture.
And here it is. Meet DeepSeek-OCR. Now, this isn't just some other document reader you might have heard of. Think of it more like a proof of concept. Its whole job is to show the world that this crazy idea of reading pictures of text actually works. So how does this thing tick? It's actually a really clever two-step dance. First, you've got the DeepEncoder. Imagine it's like a super high-tech scanner. It takes a super sharp image of the text and boils it down into a compact visual summary. Then, step 2, a powerful language model. This one's a mixture of experts decoder, takes that little summary and reconstructs the original text perfectly. So you compress it down and then you decompress it back up. Super slick.
All right, the theory is really cool for sure, but the big question is, does it actually work in the real world? Let's peel back the layers on DeepSeek-OCR and check out the results.
Yeah, this is the million-dollar question, isn't it? I mean, how effective is this whole optical compression thing? How much text can you really cram into a picture before you start losing important details?
The answer? It's pretty mind-blowing, actually. 10 times. A 10-to-1 compression ratio. Just to put that in perspective, if a piece of text normally takes, let's say, 1,000 text tokens to process, this model can do it with only about 100 vision tokens.
But wait, here's the real kicker. You'd think with that much compression, you'd lose a ton of information, right? Nope. The accuracy for getting the original text back is nearly 97%. You lose almost nothing. It's incredible.
So let's just let that sink in. You get a 10-fold boost in efficiency, and you sacrifice a tiny, almost unnoticeable amount of precision. This is a huge deal. It proves that these smaller, more compact language models can totally learn how to read these compressed pictures of text. And this chart just shows you how staggering the difference is. Look at this. On a standard test, a really powerful model called Minoru 2.0 needed almost 7,000 vision tokens to get through a document. DeepSeek-OCR, it did the same job with less than 800. We're not talking about a small improvement here. This is a whole other level of efficiency. Okay, so this is obviously super impressive. But the real story here goes way beyond just reading documents a little faster. This is about what this whole concept could mean for the future of AI itself. So why should you care about all this? Well, because this might just be the key to solving that giant AI memory problem we talked about. This whole method of squishing old information down into images, it could be the blueprint for a brand new, super efficient memory system for all AI. And this is where it gets really mind-bending.
You can actually use this to mimic how human memory works, including forgetting. Think about it. The newest, most recent memories, they're like a high-resolution, crystal-clear photo. But as a memory gets older, you can just downsize the image, right? It gets a little blurrier, uses fewer resources. And those really distant memories from way back, they're just tiny thumbnails. They take up practically no space at all, but they're still there if you need to zoom in.
The potential here is just massive. We're talking about AIs that could handle pretty much unlimited amounts of context, because the older stuff just keeps getting smaller and smaller. It's way more efficient, it feels more natural, almost human-like. And best of all, it would be so much cheaper to run.
So yeah, everything we're seeing here points to a completely new and frankly super exciting future for how we even think about what AI memory is. So, I want to leave you with this final thought. For so long, we've thought of an AI's perfect, flawless memory is its greatest strength, right? But what if its true potential is only unlocked when it learns how to manage information the way we do? When it learns not just how to remember, but also how to forget?